Thank you. Thank you, Nishta, and a very warm welcome to everyone. Um, Today, on behalf of MRC, will be giving a quick rundown of the innovation portfolio that we have in MRC, um, given the 10-minute time limit that I have. Um, as Arnab sir explained about the UDA framework, here I'd like to try and justify how we realize that UDA framework and what is the flow that we take into account. So there are four strategic pillars of innovation when we talk about innovation at MRC: science and research, technology development, policy governance, and capacity building. And each of these pillars support each other. So the base foundation is obtained via the science and research work. Then we develop applications on top of that, trying to meet the real world requirements. Then that enables sustainable policy governance, not rather than being a reactive policy, more of a actionable policy governance we that enables. And lastly, the capacity building is basically our way of giving back to the community and basically helping the community from all the things that we have learned. Um, so starting with science and research, just to throw a few numbers here, MRC has 52 peer-reviewed publications in journals that are index journals that are present throughout the globe, and 128 publications as part of research notes that are contributed by our interns and engineers and fellows as well. This we have been doing for the past 6 years, and we are working on this across 9 separate domains. Domains being AUV design and development, sonar simulation, shipping noise mapping, sediment management, climate change and environmental impact studies, collision avoidance, navigation system, and much more. And all of this is when we say interns, these interns belong to some of the most premier institutes across the globe, not just India, and they are multidisciplinary in nature. They come from multiple backgrounds, from arts, finance, engineering, pure science, and so on. As you hear the interns in the past as well as in the upcoming and today's webinar, you'll realize the difference in the projects and the wide domains that they touch upon. Um, Now, we take extreme pride in the work that we do. However, given that time limit, we won't be able to go through every research that we have performed. However, just to give a quick recap of the presentations that were showcased in the last part of the webinar, to basically help and understand the breadth of the work that is happening by interns at MRC, because today is all about interns. Some of the projects that we have undertaken this year is being dark ship detection and classification, basically using the SAR images, satellite images, to understand where the ships are present, and using and collaborating that with the AIS data, which is basically a transponder data that is received by the port, and collaborating that to understand which of the ships that is present here, that is present in the region, is a dark ship, which is dark ship as in they have turned the AIS transponder off and there is no way for us to track them. So we use satellite images, we capture those, we categorize those ships, and we try to identify whether they are fishing vessels or they are large cargo vessels. And this is extremely crucial from a maritime security perspective, because most of the threats that we see today, it's coming from the waterway, be it the 2611 attack or otherwise. Potential fishing zone identifications. Our interaction with the coastal communities have enabled us to identify that there is a requirement where we need to help the community back in identifying the fishing zones, where potentially they can perform sustainable fishing practices. Sediment bed load prediction using satellite, AI-based sound transmission loss estimation. This is again a very extremely important work that we are doing, wherein we're using a neural network to estimate the sound transmission loss. So whenever a ship or any kind of sound signal gets transmitted in the underwater, uh, existing mathematical models takes a lot of time for computation, because there is a lot of, we need to take the environmental factors into consideration. There are a whole lot of computation that goes into picture in this one. But with the advent of AI, this allows us to train a model specific to a particular region, and as a result of which we get quick results, to give a performance analysis from 15 minutes to 15 seconds, kind of a difference in execution time, is what we basically saw. The graph that you can see on the top right, it represents that what we have predicted, which is basically the blue dot, is what we is also mapping with the ideal chart that we see from the existing mathematical models per se. Sediment classification in Ujjaini Reservoir, understanding what kind of sediment bed load is there and what is the type of the sediment is extremely important, whether it is a clay silt or sandy silt and so on. Safeguarding the undersea cables, again, it's an extremely crucial issue that has been present in the community today. Understanding where the undersea cables are present and how we can safeguard them further is one more work that has been happening. Now, this was all about the research work, the initial work that we do. Again, there's a lot more work than this as I represented here. But all of this research then goes ahead and we basically create a tool out of these things. Again, all of these tools that we create are cloud-based. It is optimized with artificial intelligence and it is community-driven. What I mean by that is that we reach back to the community, we take inputs from them, and we make sure that it is something that is usable by the community and it is important and it gives them advantage. Uh, two of the notable tools is shrimp farming. One is for shrimp farming. Shrimp farming, again, India being one of the largest exporter of shrimps, it's extremely important. We have a huge economic growth potential in that particular region. So an area productive and yield analysis tool which tells exactly how much increase in the accuracy can happen for a particular shrimp in the given region, given their environmental parameters. And this will essentially reduce the input of cost because they will not increase the feed because they know that increasing the feed will not yield them the kind of results that they are hoping for. And it enables evidence-based aquaculture farming. The other tool is the SRN estimation tool. We'll play a small video at the end of my presentation to uh, explain further on this one. This is again some a work that we have recently finished and we are very proud of. I won't take too much time on this one either. But essentially a tool that allows you to estimate the noise in real time and understand the historical noise based upon a whole lot of again the environmental parameters where the ship is present, what is the wind in the particular region and so on. We take all of that into factor and then we estimate the noise level. So again, the SRN tool that you can see here is what we have, and it basically allows you to correlate the presence of ship in the region and what is the overall noise level that is being generated by the ships. And we do this for multiple frequency ranges and across the whole Indian Ocean region area. Now, the biggest ever project that we have built upon, and we are in the almost final stages of finishing this one, is the Marine Spatial Planning Toolkit, which essentially allows you to collaborate all kinds of information. As I said, we have developed a lot of toolkits in the past, and this one particular tool allows to encompass everything in a single place, in a single area, where you can basically see what is the ship noise, where is the acoustic habitat. So imagine understanding what kind of ship noise is there in the region and also being able to look at what is the migration patterns and the habitat of blue whales and a lot of more information. What are the ships in ports? Where are the undersea cables and pipelines laid out? One particular interface where you can see all of that. It helps a lot in policy governance. It helps a lot in terms of understanding the environmental impact assessment for any kind of construction projects or otherwise. So we see, marine special planning is not just something that we are picked up. This has been something that is being globally driven by the IMO, and MRC is proud to be part of the Indian team that is part of this IMO initiative, the Glow Noise initiative. Coming to the policy governance, again, whatever we generate from whatever we create a tool out of that enables us to create policies. MRC has, again, we have provided policy recommendations as part of India for NEPC 76 and 81. And as you can see, underwater noise is something that has been taken into consideration. So the idea that I'm trying to print out is that we need tools. So science enables tools, and these kind of tools enables us to understand what kind of impact does shipping noise have, and that enables us to then perform policy recommendations. Now, beyond just the shipping noise and marine spatial planning, we also are doing case study on geoeconomics for UDA and IOR, accounting framework for blue economy in UDA, and Brahmaputra basin river management, and a whole lot of other policy works that we have published in our platforms. Now, lastly, again, as I said, we need to give back to the community. We need to understand how the community and we need to increase the awareness. It is not just about us doing some work, but it is also about teaching or increasing the awareness to youngsters and other interested stakeholders alike. And so we have three platforms, which is extremely crucial. The UDA Digest, which is an open access general public platform. Anyone can access these. We have 120 plus articles present here, which is essentially written by experts and interns and everyone. And these are all in a very not so nuanced and technical, but rather more in terms of easily understandable way, while still showcasing the importance of underwater domain awareness. This is the UDA Digest platform that anyone I would request can visit. Then we have the UDA Knowledge Center. So all the research work that we have done, everything is again present in open access as research articles, technical articles with results and conclusions and everything that is present as a UDA Knowledge Center platform. Again, everyone has access to it, and this basically enables not just us, but also for the few interns and the students who are coming to us, they also refer to these kind of technical notes to see what has happened in the past and allows us to build on top of that. Lastly, we have Learning Center. Again, Nishta has already represented it. Whatever we have created, we create courses on top of that and all those things. And these are not just for basics of underwater world, but everything climate change, shipping noise mapping, blue economy. All of these courses are added to our UDA Learning Center, and it allows anyone to access and learn more about underwater domain awareness, which is something that we as a country definitely needs to take the pioneering effort of. Lastly, we have done a lot of field visits and community engagement where we reach to Gujarat, Veerawal coastline. We try to understand what is the requirement of the farmers. We give them the ship APY tool that I showcased. We basically tell them what the tool we have, how this can help them, and we received some really good feedback from them and the usage for this particular tool. So yes, I finished this year with my 10-minute time. With climate change, geopolitics, and technological shifts converging, we must lead UDA innovation. We are aptly placed in the IOR for the same. And at MRC, we aren't just ready, we have already built the foundation for this particular work. Now, just to give a quick sneak peek of one of the tools that we have recently built, this is production ready and available for anyone to use at this moment.
What if the ocean isn't as silent as it seems? Every day, global shipping fleets generate massive underwater noise, unseen, unheard by us, but deeply disruptive to marine life. This noise pollution affects not just whales and dolphins, it impacts the entire marine ecosystem. But now we have a way to measure it, manage it, and reduce it with science. Introducing the Shipping Radiated Noise Estimation Tool, or SRN tool, from the Maritime Research Center, Pune, a smart AI-powered platform that turns raw shipping data into actionable underwater noise insights. The SRN tool uses advanced AI models built on published research by MRC to calculate how ship-generated noise spreads underwater, a process called transmission loss. It considers real-world conditions like water depth, temperature, salinity, and seabed structure. This makes the tool accurate, not just visually impressive. The cumulative noise map lets you explore long-term trends, pick a region and a date range, and instantly visualize average underwater noise levels anywhere in the ocean. Live ship data is integrated, so you always know which vessel is contributing what and where. Need a live snapshot. The instantaneous noise map shows real-time noise levels with bathymetric layers that reveal how ocean depth affects noise propagation. Every estimate is backed by AI-driven models built by MRC. No generic guesses, but science-based predictions grounded in years of research. And the applications, they go far beyond just protecting marine mammals. Deploying underwater sensors, SRN helps find low-noise zones for better data. Conducting an environmental impact assessment, SRN gives you the noise exposure data you need. Formulating regulations or standards, SRN shows exactly where noise exceeds acceptable limits. This tool is a backbone for smart, science-based ocean governance. Download custom maps, export datasets, or generate reports. It's all just a few clicks away. Built for the cloud, the SRN tool works from anywhere. You don't need specialized hardware, just a browser. By making underwater noise visible, the SRN tool gives us a chance to act, to plan better, regulate smarter, and protect deeper. All thanks to cutting-edge AI, open research, and the vision of the Maritime Research Center, Pune. The ocean has been quiet for too long. Now it's time to listen.
Right. And with that, I'll end my presentation. I hope that was